The final piece of this third part, updating the TriState Fertilizer Recommendations, is going to be talking about some of the specifics of fertilizer rates and recommendations themselves. Okay, so we'll spend a teeny bit of time talking about grain nutrient removal rates because we recognize that grain removal, crop removal, whether that be in the grain itself or, say, in the case of alfalfa or corn silage, the total nutrient involved in whatever that harvestable product, whether that be forage or stover, what that's removed, it's typically applied to crop removal when soils are in maintenance, or crop removal plus a little bit extra if they're less than that. Okay. So again, looking at our fertilizer trials, how many we had spent a lot of money, invested a lot in trying to analyze samples for corn, soybean, and wheat across a lot of different plots, a lot of different sites, different soil types, soil test levels, etc., etc. So each one of these came from, there was not nearly this many trials, but each trial had multiple observations per trial, right? So we took a representative sample from each one of those and had that analyzed for nutrient content. So when we ask the question, how much nutrient is removed from your field, this can be estimated relatively easily. We essentially take how much yield or what that harvestable product was, we multiply by the nutrient concentration, okay, and that gives us how much nutrient was there on a per pound basis. So an example is if we have 180 bushel corn crop, corn, the concentration of P2O5 in grain is, say, 0.35 pounds per bushel, and we multiply 180 by 0.35 and we get 62 pounds of P2O5 per acre. Okay, so that's our total on a per acre basis, our total grain nutrient removal rate. All right. So we can do this, and we have done this, looking at yield versus grain nutrient removed in pounds per acre. Okay, so we can look at something like we just talked about corn, 180 bushel, and we take it up here. Now this is elemental P, so it's a little different, but we can see there's quite a bit of range in terms of how much nutrient might be removed depending on the crop. Like the distribution here is a little bit different. Can be narrow or wide. For the case of wheat and potassium, it's quite wide, so a little bit hard to predict. But suffice it to say that grain yield is a very good predictor, or at least a reasonably good predictor of grain nutrient removal rate. So we're not going to ask farmers to be analyzing every single grain sample they pull off their field. We can use these rule of thumbs, but understanding that there is variability or spread of the data. You can just look at nitrogen in corn versus nitrogen in soybean, much tighter relationship in soybean than in corn. And this is a kind of a big ugly table. Again, you can look at this fact sheet, a little hyperlink there, and we can take and we have calculated nitrogen, P2O5, K2O, blah, blah, all the different nutrients for every pound, how many pounds of nutrient per bushel of grain, right? So in the case of nitrogen, on average, 0.75, 0.74 pounds of elemental nitrogen per bushel of corn grain, 3.55 per bushel of soybean, and about 1 per bushel of wheat. And so we can take this number on a per bushel basis, multiply by what it would be an average yield, or whatever that means, say 180 bushels here. So if we take 0.74 multiplied by 180, we get 134 pounds of N that's getting pulled off in that corn harvest, okay? So you can do this for a lot of things, and you can see when we get down into these micronutrients how little we're actually pulling off in a harvest. So it's pretty incredible when you think for soybean you're pulling off, average soybean yield you're pulling, or a little bit above average soybean yield, you're pulling off over 200 pounds of N, but less than a pound of really all these micros. Okay, so this is a very effective way thinking about nutrient budgeting, and just you can look at it from a long-term budgeting perspective and say, okay, if I'm typically pulling off 62 and 47, maybe 100, 110 bushels or pounds of P2O5 in a corn soybean rotation, how much am I applying every year, or how much am I applying over the course of that rotation, and does that add up? Where are my soil test levels? If my soil test levels are in range, and I'm applying, say, 200 pounds of P2O5 every year or every rotation, and we're only pulling off, say, 110, 100, 110, then we're likely spending much more on fertilizer and over applying, and then we should start seeing those soil test levels build, and that's not that's not what makes for profitable farming. So all right, we can look at the old TriStates that have published how many pounds of P2O5 per bushel of corn, and then we can look at our new data, okay? And then we can see in general, across the board, we see decreases in grain concentration. Okay, the nutrients of phosphorus and potassium in grain is decreasing. And so you can look at this a number of ways. You can say, oh, well, that means that our crops are doing more with less. They're becoming more efficient. And that's true. So for every bushel of corn, it's requiring less, removing less of phosphorus and potassium. The other way to look at it is, well, our nutrients are just getting diluted in our food system, right? And so with breeding, our hybrids are more productive now than ever, and we don't select for phosphorus or potassium concentration, or really very little selection happens for actual grain, the nutrients in the grain itself. Wheat would be an exception for that, but for corn and soybean, for the most part, there is some selection for oils and lipid content and fat content in soybean, but in a general sense, that's not what's driving that breeding program. The breeding program is primarily driven by yields, okay? And this is a kind of an unintended consequence of that. So just we have to deal. I mean, there's a lot that can be said about this, and we could explore this even further. But for the context of what we're talking about here, which is nutrient management, we see that we're removing less on a per bushel basis, and so that means that we should likely be applying less. And sometimes it's 5 or 1% less, not a big deal. But in the case of potassium, for corn, 26%, 20% for soybean, 35% for wheat. So pretty large differences in terms of how much K is being removed from those crops. Okay, so it's significant. For the sake of ease, again, this is the human dimension of generating fertilizer recommendations. We can look at these new numbers here: 0.79, 1.14, 0.49, 0.25. What I've done is I've taken them and I'm rounded them up so they're numbers that people can remember. Is that perfect? No, but does it mean much? It means maybe a difference of about a pound of nutrient on a per acre basis that would change the fertilizer rate. So I made the decision that it's not important. What's more important to have, if it's 0.79 or 0.8, we're not going to be perfectly sure of what that number is, but this is going to be a lot easier number to remember. And so people will commit this to memory over time, I believe. Okay, so again, when our fertilizer rates, and these are tables that are going to be in the new TriStates, but we can take these numbers And when our fertilizer rates are in maintenance, that is, they're in this optimal level, we can take 100, like say 200 bushel of corn multiplied by 0.35, and we get 70 pounds of P2O5 per acre. Okay, so these, in kind of a nutshell, are really the new recommendations, and it's relatively succinct. This is if soils are in the maintenance range themselves. Okay, but let's talk a little bit about the process. Now, unfortunately, I don't have the new recs to show you. I mean, there's a draft that's getting vetted internally that's going to be out again in the next couple months, and I welcome you all to take a look at that when it gets released. But for now, let's use the old recommendations, but a very similar framework, the same concepts, to kind of generate some of these fertilizer recommendations. Okay, so this is an important piece, a final piece to this that will, I think, is good to kind of keep people honest and help you, provide you with some tools to do this in the future. Okay, so again, there's not my animations turned off here, but as an example, you get a soil test result back that indicates you have a value of 17 part per million Bray phosphorus. The question is, how much P2O5 or fertilizer do you need to apply for your fertility needs for this year's soybean crop? Okay, so if you pull this TriState PDF document that's on the Carmen site, you can find these tables. Table 15 is a phosphate recommendation for soybeans. Okay, and again, we said that yield drives fertilizer recommendations. We have yield in bushel per acre for soybeans here, and then we have our soil test level on this left-hand column. Part per million in that first number, and then pounds per acre, which is double that value, right, in parentheses. So we had a value of 17, so 17 puts us in that maintenance range right here. And we don't really know what that rate is until we know what our crop removal or estimated crop removal. And so we would suggest that you use historical information. What has it yielded in the last 3 years, for example, and then base it on that. So if it's a 60 bushel soybean field, if that's what you're hoping to grow, and we're at 17, we're going to be applying phosphorus at that maintenance level. And so we say 60, we draw it over to our soil test level, and that gives you 50 pounds of P2O5 per acre. Okay, so that's your fertilizer rate. That's your recommendation. All right, and you can see, not surprisingly, as your yield decreases, your rate decreases. And as your soil test levels decrease, your rates increase, because you're not just applying for crop removal, but when it's less, right, in this 5 and 10, you're applying crop removal plus building. Likewise, if it's greater, crop removal, less than crop removal is in your drawdown range. So here's maintenance, here's your buildup, and then here's your drawdown. And that's how these tables are structured. And they'll stay like this for the sake of continuity for this next version. All right, so let's ask a little bit more of a realistic example, and say you get a soil test back, and it indicates you have a value of 10 part per million phosphorus. The question is, how much DAP, diammonium phosphate, do you need to apply for your fertility needs for the next corn and soybean rotation? Okay. So this is more nuanced, and we've got to kind of think through this. So the first step is determining the correct units for the tri-states. The tri-states are in Bray, and we just talked about if they were in Malek 3, we'd have to convert by dividing by 1.3 to take it from Malek to Bray. But since it's already in Bray, no conversion is necessary. So we've got a 10 part per million. The second step is to calculate your realistic yield potential for corn and soybeans. So, there's different ways that we can do this. Take the yields over that field last 5 years, admit your best and worst year, and average the remaining 3. Take your last 2 or 3, like whatever you want to do to make this realistic. Just a realistic yield potential, not what you really want to grow. But so imagine it's 160 bushels for corn and 50 bushels for soybean. That's what we'll go with, okay? Again, we've got table 13, which is phosphate for corn, table 15, phosphate for soybeans. 160 bushel corn, 50 bushel soybeans, and our soil test value is 10 part per million. So it's 85 pounds of P2O5 per acre for the corn crop, and 65 pounds of P2O5 per acre for the soybean crop. So we add those together, we get 150 pounds of P2O5 per acre. Now, is that your fertilizer recommendation? It is, but it's typically not particularly, well, it might not be that useful because we don't have fertilizer that's 100%. We don't have anything that's 100, right? It's not 100% P2O5. So the question was about DAP. How much DAP do you need, diammonium phosphate? And so DAP, now we have to convert the weight of the fertilizer because the fertilizer isn't pure P2O5. It's 1846O. It's only 40% P2O5 by weight. So in other words, we have to take this and we have to divide by 0.46, or I structured it this way so the units would cancel. You've got pounds of P2O5 per acre. We got 1 pound of DAP is 0.46 pounds of P2O5. Those units cancel, the P2O5 units cancel, and we get 326 pounds of DAP per acre. So roughly 325 pounds is what we're going to need. Okay, so that's our fertilizer rate. This is really the process, and it's important that you know and understand how to do this. So when you move into your career, regardless what you do, you can help. At least if you're getting a recommendation from a lab or from a consultant or something, it can help keep them honest or just double check their work. So it's a really important piece. Okay. Now, for the tri-states, unlike phosphorus, potassium recommendations for the tri-state recommendations are based on CEC. So it's the same process, but the first thing you have to do is look at your soil CEC, and it gets binned into either 5 milliequivalent, and there's no, it doesn't tell you if you should round up or down, so you just have to make your best guess here. If you've got like a CEC of 7.5, you have to decide if it goes into this 5 bin or this 10 bin. But, oopsies, 5 milliequivalents, 10 milliequivalents, 20 milliequivalents. And so, again, say if you have a CEC of 9, you're going to bin it into 10, and say a yield potential for corn, say 160 bushels, and say you're in maintenance range, which is 100 to 130. That's going to give you a K2O, pounds of K2O per acre of 65. Okay, so it's just like this phosphorus, except you have an initial step of finding the CEC level first, and then your yield potential and your soil test value. Okay, that's how you generate that recommendation. And again, for K2O, we talked about most everything. The vast majority of potassium fertilizer is 0.060. So we take that value, in this case 65 pounds. We have to divide this by 0.60, which, again, if we think about this, anytime, if our no fertilizer we have is 100% anything, so the rate of pounds of P2O5, pounds of K2O, when we convert it to the actual product we're going to use, it's going to be a higher value, right? Because that product isn't pure fertilizer; it's got other stuff in it. So, anyways, that's really how those tables exist now and will continue to exist into the future. I do want to mention just really quick, kind of to wrap things up, these two different approaches, and we'll deal a little bit more with this in a few weeks, but the build and maintenance approach, kind of philosophically, is about feeding the soil, applying enough to feed that soil, and then the soil values will buffer, it will provide a lot of buffering potential for that soil to feed the crop. The sufficiency approach is kind of related to that. I mean, but it's really about feeding the plant. Okay, and so there are people, philosophies out there, mostly crop consultants, and we try. There's people that have tried to combat this idea that, oh, I don't need to soil test. All I need to do is figure out what that crop is, what our removal rate from that crop is, and I'm just going to fertilize at that removal rate. And at least I know I'm not mining the soil, and I can save myself all the time and hassle of soil testing, right? So that's it's one approach. It's really short-sighted, and we certainly don't recommend that. It takes time and energy and money to invest in soil testing, but it's an important piece. And just even if you're going to soil test for nothing but pH itself, it would be worth the expense of doing that, in my opinion. Okay. So again, like what people might do, they use these yield maps, which are coming from their their combines, yield monitors that basically say how much any given part of that field is yielding. It gives you very kind of high resolution data about a field, and then you might go in and you apply fertilizer based on removal rates. So it's an approach that's out there. It's not something that we really endorse because of all the reasons that we've talked about. Okay. And my last slide, I'm going to thank everyone for bearing with all the talk about tri-states. I realize that some people aren't here for agronomic crops, but it's just kind of the nature of the beast. I will say that a lot of the stuff that we have already, that we have talked about, this applying at removal rates, there's a good calculator here, again, IPNI, and it's not just agronomic crops, but it's all kinds of stuff, horticultural crops, et cetera, et cetera. So this provides reference for when you remove, say, a ton of tomatoes or whatever it might be, how much nutrient are you removing there? So just as an example, there are reference values that are online that you can find for determining removal rates. And so these same concepts don't have to apply just to corn and soybeans, but they can apply to horticultural crops or specialty crops of any sort, turf for even in that matter. So, all right, I'm going to end there. That's going to be all the material that we cover for week 9. So, thank you.